Welcome to Space Oddities and An Astronomical Life. Fred Hoyle, 1915 to 2001. Fred Hoyle proved that the great majority of natural elements in the periodic table were made inside stars and distributed through space by supernova explosions. He also coined the phrase Big Bang, while strenuously denying that there had ever been one. He argued for an expanding, steady-state universe with no beginning or end. A controversial, often outspoken scientist, he never received a Nobel Prize, even though his work on the creation of chemical elements undoubtedly merited one. He delighted in taking dissenting positions on many of science's big questions. He argued that the physical and chemical properties of the universe had been intelligently designed, and that life on Earth had been seeded from space. Early life and education. Fred Hoyle was born on June the 24th, 1915, in Bingley, Yorkshire, England. His father, Ben Hoyle, was a wool merchant, and his mother, Mabel, was a teacher, so had a deep interest in education. Hoyle attended Bingley Grammar School, where he developed a strong interest in science, especially astronomy. In 1933, Hoyle enrolled in Emmanuel College, Cambridge, to study mathematics. He later shifted his focus to astrophysics. During World War II, Hoyle worked with the Admiralty on radar development, a crucial technology for the war effort. His work during the war introduced him to other significant scientists, including Hermann Bondi and Thomas Gold. After the war, Hoyle returned to Cambridge and became a lecturer in mathematics. The steady-state theory. Alongside Hermann Bondi and Thomas Gold, Hoyle developed the steady-state theory of the universe in 1948, which proposed that the universe is eternal and unchanging on a large scale. One of the key ideas is that matter is continuously created to keep the universe's density constant despite its expansion. Rejection of the Big Bang. Hoyle was a vocal critic of the Big Bang theory, famously coining the term Big Bang in a radio broadcast as a term of derision. Carbon-12 formation. His prediction of the resonance level in the carbon-12 nucleus, which was crucial for the synthesis of carbon in stars, was confirmed experimentally and is considered one of his greatest achievements. Nuclear synthesis. Hoyle made groundbreaking contributions to the understanding of how elements are formed in stars. Hoyle, in 1957, along with his co-workers Margaret Burbidge, Geoffrey Burbidge, and William A. Fowler, published one of the most famous papers in the history of astrophysics, Synthesis of the Elements in the Stars, informally entitled B2FH paper, after the surnames of its authors, Burbidge, Fowler, and Hoyle. Later career and controversies. Hoyle played a pivotal role in founding the Institute of Astronomy at Cambridge in 1967 and served as its first director. He resigned from his post in Cambridge in 1972, partly due to disagreements over university policies and funding for scientific research. Contribution to other scientific fields. Cosmology and astrobiology. Hoyle was an early advocate for the idea that life could be widespread in the universe, and that interstellar dust could be composed of organic compounds. Panspermia hypothesis. He supported and advanced the panspermia hypothesis, which suggests that life on Earth may have been seeded from space. Viruses from space. Hoyle, along with Chandra Vikramasinghe, proposed that viruses and bacteria from space could be responsible for epidemics on Earth. Writing and public engagement. Popular science books. Hoyle was an adept science communicator and wrote several popular science books, including The Nature of the Universe in 1950 and The Frontiers of Astronomy in 1955, and also Our Place in the Cosmos. As well as his science book, he also wrote science fiction novels, most notably The Black Cloud in 1957, which explores the impact of a giant interstellar cloud passing through the solar system. Hoyle also reached a wider audience through his BBC radio broadcasts, where he explained complex scientific ideas in an accessible manner. Recognition and awards. He was elected a Fellow of the Royal Society in 1957. Hoyle received the Royal Medal in 1974 for his work in theoretical physics and cosmology. He was also knighted in 1972 for his contributions to science. Gold Medal of the Royal Astronomical Society. Hoyle was awarded this prestigious medal in 1968. Throughout his career, Hoyle received numerous other awards and honorary degrees for his contributions to science and public understanding of science. Controversial views and later years. Rejection of the Big Bang. Hoyle continued to reject the Big Bang theory despite increasing evidence supporting it, which isolated him from much of the mainstream scientific community. Viruses from space theory. His belief in the panspermia hypothesis and that viruses could come from space was also controversial and not widely accepted. Climate change skepticism. In his later years, Hoyle was skeptical of the mainstream views on climate change, which further distanced him from the scientific community. Personal life and legacy. Hoyle married Barbara Clark in 1939, and they had two children, Jethry and Elizabeth. Hoyle passed away on August 20th, 2001 in Bournemouth, England. Hoyle's contribution to our understanding of the universe, particularly in the field of nuclear synthesis, remains highly influential. His advocacy for ideas outside the mainstream highlights the importance of challenging established scientific paradigms, even if not all such challenges prove correct. A quick summary of Hoyle's major works. Scientific books. The Nature of the Universe, 1950. Frontiers of Astronomy, 1955. Galaxies, Nuclei and Quasars, 1965. The Intelligent Universe, 1983. Scientific papers. Numerous papers on stellar nuclear synthesis, the steady-state theory, and other astronomical phenomena. Science fiction books. The Black Cloud, 1957. October the 1st is Too Late, 1966. A for Andromeda, 1962, co-written with John Elliott. Hoyle's influence on modern science. Stellar nuclear synthesis. Hoyle's work in this area remains foundational, explaining the formation of heavy elements in stars. Popularizing science. Through his books and broadcasts, Hoyle inspired many to take an interest in astronomy and cosmology. Steady-state theory. Although ultimately disproven, the steady-state theory spurred significant research and debate, contributing to a deeper understanding of cosmology. Final thoughts. Iconoclast. Hoyle's career was marked by his willingness to challenge established ideas and propose bold theories. Scientific contributions. Despite some of his more controversial views, his contributions to our understanding of the universe are undeniable and continue to be celebrated in the scientific community. Climate change skepticism. In his later years, Hoyle was skeptical of the mainstream views on climate change, which further distanced him from the scientific community. Nobel Prize controversy. In 1983, William A. Fowler received a half share of the Nobel Prize in Physics for his theoretical and experimental studies of the nuclear reactions of importance in the formation of the chemical elements in the universe. Hoyle received no prize. Fowler himself acknowledged Hoyle as the pioneer of stellar nuclear synthesis. One of the B2FH paper authors, Geoffrey Burbridge, wrote in 2008, Hoyle should have been awarded a Nobel Prize for this and other work. On the basis of my private correspondence, I believe that a major reason for his exclusion was that W.A. Fowler was wrongly believed to be the leader of this group. Other theories about why Hoyle received no prize include 1. His criticism of the Nobel Committee for awarding Anthony Hewish a share of the 1974 Nobel Prize in Physics for the discovery of pulsars, but making no award to his research student Jocelyn Bell Burnell, who actually made the discovery. 2. His persistence in championing the steady-state universe rather than accepting mainstream Big Bang universe. His support for unorthodox ideas such as panspermia. The support for unorthodox ideas argument could also have been used to prevent Linus Pauling getting the Chemistry Nobel Prize, but fortunately for Pauling, his unorthodox ideas came after he had been awarded the prize. I hope you enjoyed this brief introduction to Sir Fred Hoyle, 1915 to 2001, and thank you again for watching Space Oddities.